So today we're going to talk about polynomial functions. And this is really, there's only one other section we're going to do in this chapter, and it will be irrational functions, which that won't be included on the test. So this is polynomial. This is higher order polynomials, x cubed or higher. And normally we do cover several sections in this book, but we're going to not do some, there's several that we're going to skip this semester. But I'll talk about zeros and multiplicities of zeros, and we'll talk about sketching a polynomial function, and then what the intermediate value theorem can tell you. So a polynomial, a generic polynomial, is this formula. Now, don't memorize this formula, but all that means is that you've got a number, all the a's are just some number. A number with x to some power, and it's going to be a fairly large power perhaps. And it goes down, you always put them in descending powers of x, so it would be x to the fourth, x to the cubed, x squared, all the way down till just something x plus some number by itself. And that's just a number theory sort of way to write an equation. So what you do need to know is this leading term. This, if you want to look at this exponent up here in this first term, or your highest power of x. If it's even, it tells you something about the graph. And it tells you that both sides go in the same direction on the end behavior. They're either up if it's positive, or they're down if it's negative. Now, depending on how high a power it is, x to the fourth, x to the sixth, x to the eighth, there may be a lot of wiggles and squiggles in between those two ends, but they're still going to both go up or both go down on each end. So you may have varieties of what it looks like in between, but the end behavior is always the same if that highest power of x is even. Does that make sense to everybody? Okay, if it's odd, it's different. If the highest power of x is odd, then it goes down on the left and up on the right. And if you can think of your cubic function, if you have that memorized, then that you can sort of picture what that looks like. And if it's negative, then it's flipped over the x, so it goes up on the left and down on the right, if there's a negative in front. So let me just add that. I'll add that to the screen. This is when a is positive. If I can see that. Can you see me writing on there? Okay, and this one is when a is negative, right? And this other case, this is when a is positive, and this is when a is negative. But the key thing is whether the exponent on your highest power of x is even or odd. And then this one can also have x to the third is a pretty straightforward graph, but x to the fifth, x to the seventh, x to the ninth can have, again, a lot of wiggles and squiggles in between, but it will still be up and down on opposite sides. Okay? So that's what that would look like in maybe a higher power of x. Okay? Now, so let's just look at this, the next one. What is our highest power of x there?
5.
It's a 5, yes. So that means it's odd. So we know the end behavior, and it's also positive. So the end behavior is going to be up on the right and down on the left. Okay? And that's all this is asking you right now, is what would the end behavior of the graph look like. Later we'll talk about how to kind of fill in the middle. All right, so now this one, something like this is a little bit tricky because you have to remember that you have to look at all the x's. This is x cubed right here, the x plus 1 cubed, but you've also got another x in that first set of parentheses, don't you? So when we multiply x cubed by another x, what do you have? You have x to what power? This is a 1 here outside. If there's nothing written, there's a 1 in that's first equation. So this is x to the first, basically, and this is x cubed, just if we think about just multiplying the first terms. So that together is going to be x to the fourth power. So you're going to have to add your exponents to find the highest power of x, and that's called the degree of the polynomial. So another thing that you might hear me refer to is the highest power of x also refers to what we call the degree of the polynomial. Okay, so we determine that it's a -2 in front, and the first term will be x to the fourth. Well, negative means what is going to happen to that? It's going to reflect. It's going to open down, and the behavior is that it's going to be the same because it's an even exponent. The other side's also going down. Both sides go the same direction when your exponent is even. Okay? So let's look and let's see if we can figure out just to answer these questions. Now remember, you're really just looking at the sign in front of the number that has in front of the highest power of x. And so in this first one, let's see, Kathy, can you tell me in this first one, what is the degree of the polynomial, or what is the highest power of x? 4, yes. And there's a negative in front, so we have an even exponent with a negative in front. Are the ends gonna both go in the same direction or in opposite directions? Same, and they're gonna go which way, up or down? Down, because there's a negative in front. Very good. Okay, let's look at B. Okay, so Emily, this is going to take a little work. What is the highest power of x here that you're going to see?
Would it be 7?
Excellent. Yes, it would be 7. And we've got a positive number in front. So an odd with a positive number in front, which direction are your ends going to go?
Wouldn't it go down to up?
Right, it's going to go down on the left and up on the right. And this is going to end up being, the degree is 7. Over here, we said it was 4, and it was a negative in front. So it's going to be down on both directions. And so if on a test I should ask you about the end behavior, that's all you have to do. You don't have to really solve anything. You just have to look at the highest power of x and whether it's positive or negative in that first term. Okay? Now, zeros and multiplicities of zeros. There are, if you notice up here in B, we have 3 different factors, don't we? And those 3 different factors are your zeros. And the multiplicity is your exponent. This x minus 9, if I wrote it all out, I'd have x minus 9 times x minus 9 times x minus 9. I'd have it written 4 times. And with this x squared, I've had x plus 4 written 2 times. And so that's why it's called a multiplicity. That exponent is called a multiplicity. And so when we go on and look at this, all those are roots and solutions. That's your x-intercepts. What we've talked about now to algebra 2, that those are sort of all those words that mean the same thing. So we want to find the zeros, and if you're given something like this, you're going to have to factor it. Now, when you have 4 terms, the easiest thing to do is to group them. And so when you group them, remember you're going to put parentheses around the first 2. I'm going the wrong direction here. Going around the first 2 and then around the second 2. Let me show you more steps than that. Okay, we're going to take, and usually what I do is I change this negative to a plus and put the negative with the 16. And then I'm going to put parentheses around the first 2, and parentheses around the second 2, okay? Now in this first group right here, I can factor out an x squared. which means you're going to divide everything by x squared. And so what you're going to be left with is x minus 5. Okay? Then in this second group, I think I can factor out a negative 16, and that's going to leave me with x minus 5. Okay? Now remember, one of your factors is what's already in parentheses. That's your x minus 5 when you're grouping. And the other factor comes from those numbers in front, here and here. Okay, so that other factor is x squared minus 16. Now the problem is here now, this x squared minus 16 can factor even more. And so anytime you have a higher power than just an x, you have to look to see if it will factor more. And that's that difference of squares factorization. So that will be x minus 5 times x minus 4 times x plus 4. And that equals 0. And so then your roots, remember how you get your roots, you set everything equal to 0. So you take all your factors and set them equal to 0 to get your solutions. And so x will be 5, x here will be 4, and this x will be negative 4. And so those are our three solutions. Now we know from looking at this that the end behavior it's an odd exponent. So we know we're going to have an end behavior going down and up, down on the left and up on the right. And we can put these three zeros at 5, 4, and negative 4 on the graph. So we're getting closer to filling in those gaps in the middle, aren't we? By factoring and finding the zeros. Now they all have a multiplicity of 1 because there's no exponents. None of them are the same, are they? So all of these are three distinct and different zeros. So that would be, your zeros would all have what we say a multiplicity of 1 because none of them are repeated. Okay, so let's look at, I'll go through their slide. And so same thing with this. Do you want me to work through this one, or do you think you've got this? I'm okay with working it, but I'm okay with skipping it too. Yes? Yes, work it. Okay. All right, so first we're going to group. Remember, I usually take that and put the negative inside the parentheses. So the first group, I can factor out a 4x squared, which will leave x minus 1. Okay. Second group, I factor out a negative 25, which leaves you with x minus 1. So in other words, I'm dividing this by negative 25 and this one by 4x squared. All right, so my two factors are 4x squared minus 25 and then x minus 1. Is this a difference of squares, the 4x squared minus 25? Can I take the square root of each of those? Esperanza, what do you think? So the answer is yes, we can. So we have 2x and 2x and 5 and 5. And remember, the signs are different, so there's a plus and a minus. So then you're going to set them equal to 0. 2x equals negative 5. So x will be negative 5 over 2. So that's going to be a little harder to graph because it's a fraction, but we could still do it. This one then will be positive 5 halves, and this is going to be 1. So our zeros are 5 halves, negative 5 halves, and 1, and they all have multiplicities of 1. Okay. All right, so this one, let's look at this one. So for this one, they have a common factor. We can factor out an x. There's not 4 terms, so we're probably not going to use grouping. But if I divide everything by x, I can have x squared plus 10 plus 25. And then that would factor as x and 5 and 5. So 5 and 5 multiply to be 25, and they add to be 10. So this one is the same as x plus 5 squared, which means now we do have a multiplicity. Okay, so this 0 here, when it's by itself, is just going to be x equals 0, and it has a multiplicity of 1. And x equals negative 5, but that one has a multiplicity of 2. Okay. Any questions so far on those? I know this has more examples, and you may or may not like that, but all right. So look, if you get a problem like this on a test, it's just find the zeros and their multiplicities. This is another one of those things that you don't have to do work on, and students often make harder than it is. But think about it. To find the zeros, you're just going to set each one equal to 0. So you could say 8x equals 0, x minus 1 equals 0, and x plus 3 equals 0. So in this, x is 0, x is 1, and x is negative 3. Now, what are our multiplicities? For the 0, that's just a multiplicity of 1. What is the multiplicity of this 1? It's 2. This one has a multiplicity of 2 because it's a squared here up in the factor. And the negative 3 has a multiplicity of what? The exponent's a 3, so it's a multiplicity of 3. Okay, any questions on that? So try not to make those harder than they are when you see those. All right, so we already kind of went through that. I'm going to kind of skip over this. This one you would have to factor. You could factor out a 2x to the 4th. And then it's a difference of squares after that. But this one we can read it straight out. So who wants to do this one? Let's see, who haven't I called on? Or hasn't answered me. Let's see. Eric, you have trouble with your audio a lot. Let's see. Jocelyn, can you answer me on this one? On A, what would be your 2 zeros that you have? Are you there? Okay. All right, I'll just answer. It's negative 3. This first one would be negative 3 because you're going to set that equal to 0, and it has a multiplicity of 4 because that's the exponent on it. The next one would be positive 1/5, and it has a multiplicity of 5. Now, if I asked you the degree of the polynomial, who knows what you would tell me?
9.
9. Yes, you add up the exponents. Okay. And now, but if it's not factored like this, if it's like this one, you just look at the highest power of x. So this one, you don't add the exponents. Do you see the difference? This one has all those parentheses and factors. This one is already just written out, and so the highest power of x is x to the 6th. There's nothing I'm going to multiply to make that x any bigger. So the difference is you add them when you see the factors. When you don't see the factors, you just look at the highest power. So that can be a little bit confusing sometimes. All right, so here we go. This is probably one of the reasons we talk about multiplicities. This one has 3 different zeros, 0, 1, and negative 3, and they're located here. And notice that they all cross the x-axis at that 0, okay? Notice it goes down on the left and up on the right because we have x times x times x, so it's an x cubed. And so what the multiplicities do is they're going to tell you whether it touches or crosses the x-axis at that 0. All right, so notice they all cross, and it's x cubed, and it follows the rule that we just said. It's going to go down on the left and up on the right. This one has a multiplicity here that one of them is even. So that one, notice what happens at that. It just touches and turns, doesn't it? It doesn't cross the x-axis. It just touches it and turns back. And so with even multiplicities, that's what's going to happen. It's going to be a touch rather than a cross. It's going to touch and turn. And so this is an x to the 4th. It's going to go up on both ends. The degree of the polynomial is 4. It's going to cross at 0 and negative 3 and just touch at that x is 1. All right, so on this one we have a x. One of our zeros is at 0 right here. One is at negative 1 or positive 1 here, and one is at negative 3. And you notice the negative 3 is a touch and turn, and the other two are crosses. Okay. So that's one thing you're going to notice as we go through and do these. Okay. So odd multiplicity, this is the summary basically. If it's an odd multiplicity, it's going to cross the x-axis. If it's an even multiplicity, it's going to touch the x-axis. So it says identify the zeros and whether there's a cross point or a touch point. So right here we have, this is x is 0. And what's it going to do, Sky, do you know? Nobody's with me today. Okay, at this one it's going to touch because it has an even multiplicity. The negative 4 is going to be a cross because that exponent's 1 if it's not written there, which is odd. And at the positive 7, it's going to cross. Any questions about the touching and crossing piece? It's when we actually have to put it together on a graph that it gets a little more complicated. All right, turning points. Within a graph, you can have a lot of different hills and valleys. And so those are called the turning points. And the turning points, any graph will have no more than the degree minus 1 turning points. So you think about a parabola, which is an x squared, right? How many turning points does it have? It can't have more than 2 minus 1 or 1. Well, a parabola obviously just has this one point right there that it turns, correct? Now an x cubed could have 2 turning points. So you look at the degree and you subtract 1 to tell you, now it may not have that many, but it can't have more than that. And so an x cubed has a kind of a turning point here and a turning point there. So there's your 2 turning points right here. Okay. So an x to the 7th could have at most how many turning points? Esperanza, are you there?
Yes, Mom.
How many? If I had x to the 7th, how many turning points might I have at most?
Wouldn't it be 6?
Yes. So it's always just 1 less than that highest power of x, or 1 less than the degree. So that helps us know a little bit about the graph too. And all these are just different things to help us know more about what the graph might look like. So here we have the maximum number of turning points. This is x cubed. So we can see in this particular graph it does have 2. Is that what's expected? Yes. Okay, it has a 3rd degree, at most 2 turns. And there they are. Okay. Sketching the function. And this is what's a little tricky sometimes. Here's just some general steps. I don't particularly use symmetry. You can. And I'm going to post this so you don't have to necessarily, do this word for word right now. but look at the end behavior, look at whether it opens down, whether it's a reflection, figure out your x-intercepts, and know your cross points and your touch points. So I don't particularly use symmetry, but you can if you know that something's symmetric like a quadratic. And then if you look at points between your zeros and get a number, sometimes that's helpful to know how high it's going to go or whether it's going to go very high or not. So the general shape of this is an x to the fourth. Here's 2 and then 1 and 1. So this is an x to the fourth. So it's going to, and it's positive, so it's going to open up on both ends. So that means it can have at most 3 turns. Okay, so you just kind of just look at the equation and gather this information. The x-intercepts are at, make your x's 0 and you find it's -1 squared and 3 and -4. Okay. And the y-intercept is at -12. You just plug in and make all the x's 0. Oh, I'm sorry. You multiply this together to find your y-intercept. Make x 0. And then you've got these factors. So here's a 0 at 1, and it's going to touch. At -3, it's going to cross, and at 4, it's going to cross. And so then with that information and your intercepts, you can put it on the graph, and they pick some points between. But you can see here's your cross here, and here's your touch. It opens up on both ends. What they're doing here is they're going between -3 and 1 and picking a point just to see about how far down it would go. And same over here, about how far down it's going to go. When you're sketching these, like for me on a test, if you get close, if you get the end behavior and the touches and the crosses correct, I'm not going to be that picky that you've exactly found these other points. Does that make sense? I want you just to know those trends of what those x-intercepts. I would like you to find the y-intercept because that's usually pretty easy. Okay, so sketch this function. It's a cubic function and it's negative. So it's going to go up on the right and down on the left. It's got at most 2 turns. Okay. And it has an intercept at -9. And the y-intercept then is at 0, -9. And your x-intercepts you can get straight from the equation. Okay, so they're -1 and 3, and it's going to touch at 3 and cross at -1. And then you plot all those points that you know and sketch in your graph. Okay, and so you can see here it crosses at -1. It comes from up here and crosses, takes your first turn and goes up and touches, and then turns back. Questions on sketching. Intermediate value theorem just means, and I don't know that I asked you any questions about this on the homework, but if I did, all it means is you plug these numbers in. It says show that this would have a 0 on the interval between -1 and 0. All right, well, if it has a 0, and let me just show you the kind of concept here, why we're talking about. So if I have a graph at -1, and here my x is 0, okay? And the graph has a 0 between those. So say it's going to come down like this, or it may be coming up like this. But if it has an actual 0 here where it crosses the x-axis between those two, notice here it's going to go from positive to negative if I put for the y value, and here it would go from negative to positive. So all you do is you plug those numbers in and see if the answer has an opposite sign. Because if it has an opposite sign, if it's positive on one side and negative on the other, then it has crossed the x-axis. Does that make sense? I'm hoping. So what you'll see is we do f of -1 and you get a 12, negative 12. Then you put in f of 0 and notice you get a positive 35. So between those two values, our graph crossed the x-axis. And so there's a 0 somewhere between -1 and 0. And that's all that intermediate value theorem tells you. If you can't find the zeros, if you can't factor or whatever, sometimes you can check intervals to see where it has a cross point or a touch point. So there's at least one 0 on that interval. And that's all you'll do if that asks you that question, is just plug those numbers in. So in this one, you'd plug in -4. Now, I'm not going to do it, but you plug in -4, see if it's positive or negative. Then you'd plug in -3 and get an answer and see if it's positive or negative. And then you'd say if it does or does not have a 0. Okay, so let me turn my